So Maxwell-Boltzmann diagrams are basically showing you that if you have a compound or a substance, there is quite a lot of molecules or particles there. So it's important to remember that the y-axis is number of particles, and they do not have exactly the same temperature or average or kinetic energy. So temperature is technically the average kinetic energy. So the temperature would be somewhere here. That's the average, and maybe somewhere slightly skewed to the peak there. That one is slightly skewed over this side, so maybe the temperature here is here. So the average kinetic energy is the temperature, and that's their spots. But you can quite clearly see that even with something that's quite cold, there'll be a very small amount of substance, this blue stuff here for the 0 degrees, that will have very high kinetic energy, but the majority of the substance will have much lower kinetic energy. So as you increase the temperature of the substance, there is a greater proportion of the molecules that have a high enough kinetic energy to overcome the activation energy, which is this red line here. So that's the energy that's needed to overcome the bond breaking in order to get the reaction to occur. So it breaks bonds and then reforms bonds. Okay, so just remember number of particles on the y-axis, kinetic energy on the x-axis, and basically increasing temperature just increases the proportion of molecules that have enough energy to react.